So, hey guys, welcome to I think this is the third video now of the series on scheduling. And as a reminder, in the previous video, we did an exercise on assignment model, and it was a minimization exercise. I think this was the exercise. And then one thing that we decided to do now is like actually we solved everything, and we found the optimal solution to be 18 miles, if I'm not mistaken. But now, one reason why I decided to come back on the minimization on this same exercise is because the exercise that we did was already optimal at the first trial. So we did step 1a, step 1b, step 2, and we didn't need to do step 3 because step 2 was already optimal. So this exercise here, we're going to use the same exercise, but I just decided to change few values to make the exercise not to be optimal on the first time, and so that we can go and use step 3 and step 4 for you to understand properly. Now, as a reminder, we have this company that is called the Green Cap, and they are trying to find the best allocation of drivers to customers so that they can minimize the cost. So they say that this is the allocation, as I was explaining. If this time we're taking driver 2, if driver 2 has to fetch customer A, is going to have to travel a distance of 5 miles, whereby if he had to fetch customer 2, you'll have to travel 4 miles. But now the advantage is like we need to find an allocation that is going to minimize the cost. Now this is the initial table. This is exactly what we did in the previous video, but now the new table that I designed is this one here. So the only difference is this value that we have here of 12 and the value of 7, if I'm not mistaken. So you find out that in the initial table you have 3a is 12, but in the initial table 3a it's 6. And on the 1C we have 7, and 1C here we have 4. Those are the only changes that I made. Now I did it because I feel like the table is not going to be optimal the first time if we do that. So let's try to find out, and let's see how we solve. Obviously we start with the first step, which is step 1a, subtracting the lowest value in the rows. So remember that you always start by subtracting in the rows, then you do the column. So from the table that we have here, we copy and paste it, and then from here what we do is like the smallest number in the row here, 7 minus 3, you get 4. 3 minus 3, you get 0. Here you get 4, and then we get a 5. Same thing here, 5 minus 4, you get a 1, and then 4 minus 4, you get a 0, you get a 2, and you get a 1. Then on this column here, 6 minus 12, you get 6 minus 12, it gives you 6. 7 minus 6, you get 1. 9 minus 6, you get 3. 6 minus 3, you get a 0. And you get a 8 minus 4, because 4 is the smallest number in the column, you get 4. And then 6 minus 4, you get 2, you get 3, and you get a 0. So step 1a is done and dusted. We go to step 2. Step 1b. Step 1b will subtract the smallest number in the columns. So we do the same thing as I told you. You move from the initial table that you already had, and the initial table, this is the one that you guys have here. Now what you do is, again, I'm gonna remove all the part here to keep a table that is a bit cleaner for you to understand. And now we look at the smallest table, the smallest number in the rows. In the row of A, the smallest number is 1, so we get 4 minus 1, which gives you 3. 1 minus 1, 0. 1 minus 6, 5. 4 minus 1, you get 4 minus 1, you get a 3. Then in this case here, we still have B, which is 0 everywhere. As I told you, whenever you have a 0 in a column or in a row that you need to subtract, nothing changes, so we're gonna leave it like this. And then we go back to the other one. 4 minus 2 gives us 2. 2 minus 2 gives us 0, and then you have 1 and you have 1. Then we do the same thing for B. Realize that we have a 0 in the column, which is nice. Now what we do is like we move to step 2. So we have step 2 that we need to minimize. We need to draw the minimum number of lines to eliminate the zeros. So we will do that using again the most recent table, which is from step 1b. Now from here, what we do is we get a 3. I remove again the calculation part so that we are on the same level. So this is the new table that we have. Again, what we do is we decide which the number that we're gonna cancel. I mean, yes, we cancel the zeros, and the way I'm gonna use this one here. So as I told you, one thing to do it is to use one line that is gonna subtract the maximum number of zero. If you look at, I can use one line to subtract the 2 zeros here. It can still work. Or the amazing thing is, like, I can use one line to subtract 3 zeros at 1, 2, 3. It's even simpler and smarter. So I insert, what am I going to do? I'm going to make another horizontal line to cancel the 3 zeros at 1 like this. Well, I'm sorry, my line is not really straight. But anyways, you understood. So we're gonna use one line to cancel all the 3 zeros like this. Then you find after canceling the zeros here, we are left with 2 zeros here and 1 0. Obviously, I'm gonna use one line to cancel these 2 zeros, and this other 0 I'm left, I can only use one line. It can either be horizontal or vertical, it doesn't change. Now the good thing is, from the allocation that we have here, we are not optimal. How many lines we have? 3. 1, 2, 3. How many columns or rows we have? 4. We have 1, 2, A, B, C, D, which is 4. The column A, B, C, D, which is 3. Should we, is there another way of allocating lines that we could have used? When I look at this table here, I don't see, but let me check. Assuming that the table was like this, obviously the first line, this one here, we cannot change it, because no matter what we are doing, it's minimizing already the maximum number. So this one is like this. Now we just need to find another way to cancel the zeros. But you understand that if we use this other one, one could have think like this. One could have thought like, we cancel this and I use another line to cancel this 0 and to cancel this other 0, and it's fine. It's more like I got 4 lines already and 4 rows, and the solution is optimal, which is wrong, because we need to use the minimum number of lines to cancel the maximum number of zeros. You cannot use 2 zeros like this. You cannot use 2 lines to cancel 2 zeros if there's a way to cancel them with 1 line. So that means here the best thing that we could have done would have only been to take 1 straight line to cancel the 0 like we. So but on this case here, I don't see another location that we can do that will maximize the number of zeros. So coming to this, you realize now that the solution is not optimal, and this is what they're saying here, that draw the minimum number of vertical and horizontal lines necessary to cover all the zeros. If the number of lines equal either the number of rows or the number of columns, proceed to step 4. Otherwise, proceed to step 3. So what, in our case here, we cannot proceed to step 4 because the number of lines does not equal to the number of rows, so it's not optimal. Now we go to the assignment method. So if the with the step 3. Step 3 is like we subtract the smallest number not covered by a line from all the uncovered number. Then we add the same number to any at the intersection of 2 lines. Then we return to step 3. So we're gonna go to step 3. So it's too much literature. I'm gonna say subtract and so on and so on. So I'm just gonna copy this part here. You're not obliged to write what you need to do in every step. I'm just doing because you guys need to know what I'm doing. So from here, this table here is a copy and paste of this other table. It's saying that we need to subtract the smallest number not covered by a line. So we go back to our table in step 2. Which one is the smallest number not covered by a line? The smallest number not covered by a line is this one here, the one that is here. Shape fill, we put no color. So this number here, let me do it in red so that catches your attention. Yes, so we get it right. This one here is the smallest number. Actually, we have 2 1. In this case, because we got two same number, we cannot get two smallest number. No. In this case, because we have 1 and 1. Otherwise, if we only add 1 and the other one we had 2, 1 should have been the smallest number. So they say that we subtract the smallest number not covered by a line from all the number uncovered. What are the numbers that are uncovered by a line? You get 3, 5, 3, and 2. They are not covered by a line. 0 is covered by a line, and so on. So we'll subtract 1 from all the numbers that are not covered. So we get this table 3 minus 1. We get 2. And in the other one, 0 is covered. 4 is not covered. 5 is not covered. So we'll take 5 minus 1. It gives us 4. And 3 minus 1. It gives us 4. 2. And then we look at the other number. This cell here, everything is covered. This one, everything is covered. And the next one is not covered. It's 2 minus 1, which gives us 1. And 0 is also covered. But 1 is not covered too. So we're going to use 1 minus 1. We get 0. And 1 minus 1 again, we get 0. So they say that what we are supposed to do is to subtract the smallest number not covered by a line from all other uncovered number. This is what we did. Then we should add the same number to any of the number at the intersection of two lines. So we go back to our lines here. Which one is at the intersection? We only get intersection is when two lines meet. So you realize that you get B2, that's where there's the first intersection, and D2, the second intersection. So we're going to add that smallest uncovered number to that part. So we go to B2, this is the part, we get 0 plus 1. And then we get a 1, and we go back to the other one. The smallest uncovered number here, it's 1 when you look at it. And if you leave the line, you realize that the smallest uncovered number, the one at the intersection is 1, and it is in D2. We look at D2 here, we get 1 plus 1, which gives you 2. So we got a table. Then apart from after that, they say we need to return to step 2. What is step 2? This is step 2. Draw the minimum number of line. This is what we're supposed to do. Then we got step 3. After doing that, we go to step 2 and check for optimality. So what we do is we take the new table from step 3, the one with all the calculations. So I'm going to erase again the numbers here so that you understand. And as I said, it's always better for you to solve it using a pencil so that after you can fix it in case there are things that need to be fixed. So yeah, then we have this. We'll remove this and this. So actually this is the new table that we got from step 3. So what we do again, we test for optimality. So the reason why I'm copying this line because I don't want to draw them again. So I'm going to use them for construction purpose. Now we realize that this row, for example, here has 3 zeros in a row. So it's easy for me to take one line here and cancel them. Then I got a line that can cancel these 2 zeros again, like this. I can use it. And how many zeros am I left with? 2. Is there a line that I can use to cancel these 2 at the same time? There's no way. So I only have this line here to cancel this, and this one here to cancel this. Is my table optimal? Obviously yes, because I got 1 2 1 2, so I got 4 lines, 4 rows, and 4 columns. My table is optimal now. Is there another way we could have used to allocate these numbers? I don't know. Let's check. So we insert a page break down here. So this is just another allocation. As I'm saying, the reason why I'm always doing 2 because there are many options, and I don't want you to think like you have to do 2 every time that you guys are working now. So, and the second table that I use is always green so that you can distinguish. It's not the same. By the time you find the optimal here, you can already proceed to the final stage, step 4. But on my case, it's just I want you guys to know what I'm doing. So obviously one thing that is not changing is the 3 zeros. Why? Because it's giving me the optimal number, one line that is canceling 4 3 zeros. I could have not asked for better. So I've done this. Now the second thing is I can also use the straight lines here to cancel this 0, because I can use a straight line like this, or I can use an horizontal. I'm not using horizontal because you already use horizontal in this row here. So I'm going to use a vertical one, and I use another vertical one here. So you understand that I'm left only with these two, that I can also use a vertical line to cancel them like this. So you understand that there's another this is the second allocation that you could have used to make it optimal. You understand that now it's optimal, and since it's optimal, what we do, we go back to, it's more like we went one step back, which was step 2. We checked the number of line, it was fine, so we don't need to go to step 3 anymore, and we go to step 4. And step 4 now is talking about the optimal number. Step 4, in this case here, where is it? Down here, we're gonna make step 4. Step 4, optimal solution. Now what do we do here? We go back to the initial table, we go back to the final table that we got, which is this one here, and we are going to try to allocate. Remember what I told you in the previous video, no matter what we are doing, we allocate the number to the one that is 0 only. So every text is going to go in a cell where there's only a 0. So we're going to do the same thing. We allocate this one here. As I said, you can also go with 8, depending on you. So how many options does one have? One only, it takes you one only as one option to go for B. It cannot go for anyone because there are no zeros, so it can only go for B. Taxi driver 2, how many options does he have? He has 2 options. He can go either with A or with C. So we have A where he can go, or C. Then we go to 3. 3 here is, how many options does he have? He has 2 options, C or D. So when I do like this, we got C or D. Then we have 4. Who is the last one? How many options does he have? Like 3, he also have C or D. So we do like C or D. Now here it's a very big problem. We know that at least one guy that is secured is only one, because he got only B. So B belongs to 1 and nobody can do it. Now we go back to 2. 2 can either do A or C. But you go back also to 3. 3 can do C or D. And then D can also do that. So you realize that it's better, since C is between 3 and 4 and 2, it's better to leave it to the others, and A can only do 2. 2 can only do A, this one here. So we can remove the C. So you understand that 2 can only do A, because that is what is left. Now we look at 3 and D. 3 and 4. 3 and 4 will be fighting between C and D. 3 can either do C or it can do D. The same thing that 4 can only do C and can only do, is what I'm talking about. 3 can do C or D, the same thing that 4 can do C and D. So what we do is, like, we can decide saying that 3 is going to take a D, is going to take C, and 4 is going to take D. Likewise, we could also decide for this one here to get a D and this other one to get a C. So I'm going to put it like this, because actually this one is a tie between bracket. So either 3 take 4, either 3 takes C or it takes D. Is going to be the same thing like if 4 takes the 2 of them. So what do? That we allocate the values. The reason why I put it like this is because I want you guys to understand that there are 2 options and all of them are matching. So you're not obliged to do it like this too. So we allocate, to go back to the initial table. The initial table here is, we say that 1 should take B and 2 A. So 1 should take B, which is 3, and 2 should take A. So we have 3 and 5. So here we have equal to 3, and here we have equal to 5, because 2A is 5 if I'm not mistaken. 2A is 5, yes. Now we will use 2 options. The first option is about 3 taking C first, 3 taking C and 4 taking D. This is what we'll do. If 3 takes C, 3 is here. If 3 takes C, we'll have 9, and 4 will take D, we will have 4. So it's 9 and 4. So we have 9 here and 4 here. Like this, we get a 4. So what solution will we have? The first solution will be the total or optimal distance. Optimal distance will be 3 plus 5, which is 8, plus 9, which is 17, plus 4, which gives us 31 and 21. 3 plus 5 plus 9 plus 4, we get 21. This is the first option, knowing that C is 3 is allocated to C and D is allocated. So one thing that I can do is like I can copy this to avoid confusion. Anyway, this is a trial that we're doing. To avoid this, I'll do this. So we get 3C and 9, and then this one here 4 takes D. Yeah. So in the other one we take 3D, and then they're just gonna swap. So if they swap, what is gonna happen is like 3 will take D. What is the value of the 3 is here in the optimal initial table. 3 will take D, which is 6. So instead of 9, we'll get a 6. And 4 will take C. So we go back to the table here, we look at 4 and C, which is 7. And we get a 7 here. Then the optimal will be 3 plus 5 plus 6 here and plus 7. Does it give 21? Normally, yes. So you get 3 plus 5 plus 6 plus 7, and you get 21. So you understand that the allocation here is still the same. Either C took D, either 3 took C, or D should have been the same, and we have reached our optimal distance. So again, to come back to like a summary of everything that we have done, we got this optimal table. The first thing that we do is like we find the smallest number in every row. In this case, it was 4. We subtracted from every number in the table, from every row. Actually, from the first row we subtract 4. Second one, the second lowest number was 1, was 4 again. Well, but the first one was 3, the second one was 4, this one was 6, and so on. And after that, we found the smallest number in a column. And remember, whenever you have a 0 in that column or in that row, then the column doesn't change, or the row doesn't change. Then we need to draw the minimum number of lines. This is what we have done, and you realize that it's not optimal because you got 2 columns. We got 2 lines, 3 lines and 4 columns, which is not optimal. So what we do, like we find the smallest uncover number, we minus it to all the numbers that are not uncover, and we add it to the number that are at the intersection. So after doing that, this is step 3, by the way, and after step 3 you go back to step 2, which is about checking the number of lines. But now I want to get your attention. If we add 3 lines again, we will go back again to this step. We find the smallest uncover number, and so on till when you find the optimal. So you'll go back to step 3, you do that, and you go back to step 2. If it's not optimal, you do the same thing. We got lucky again on my side. After the second trial was optimal. On your side, you might even have to go to the 3rd trial. So it depends. But remember, after that, you still allocate it based on the initial table. So this is the first allocation in blue. This is the second one that you could have tried to allocate, still be this to check the optimality, and then we found the optimal solution from here. So this is what we did. I really hope that this video was also helpful, and thank you so much for your time. In the next video, we're going to talk about the priority rules. And thank you so much for watching this video. Please don't forget to subscribe to the page, and so that you'll be notified for the next videos. Thank you so much for your time, and see you next time.